We know the answer not only to your energy, but to what makes other stars in the universe shine. Thermonuclear reaction. It's the key word that wound up the universe. Thermonuclear.
8 to 5, they've made a hydrogen bomb.
We certainly have, Mr. Sun.
And the news rocked the world.
But with you, it's old stuff. The equivalent of 4 billion hydrogen bombs have been going off inside you every second for some 4 billion years.
Give or take a billion.
What smart guy figured that out?
Dr. Hans Bethe of Cornell is the gentleman. In 1938, he announced that the source of the sun's energy is the fusion of 564 million tons of hydrogen into 560 million tons of helium each second.
564 to 560, where did the missing 4 million tons go? Just disappear?
Disappears as mass, as matter, but reappears as light, heat, and all sorts of radiation.
Quite a trickster old Saul making 4 million tons disappear. 4 million tons?
That he is. Roll 12. I brought along a trickster friend of mine, Thermo the Magician, who has an act which he claims explains the sun's magic.
I am Thermo. I will do for you such a trick only me and the stars can do. Pay attention. This is one way to make a hydrogen bomb. Nature's way. So, hydrogen. 1, 2, 3, 4. What is hydrogen? The smallest atom from which you build all the other atoms. So, we will weigh the hydrogen. Scale. Each bottle weighs exactly 100 ounces. 4 bottles, 400 ounces. Remember that, 400 ounces. So, now, carbon. This is carbon. A piece of coal to you. That is what I start with. Hydrogen and carbon. So, now I will heat them. 30 million degrees I will heat them. How? In a hydrogen bomb, it is done by exploding an ordinary atom bomb to ignite the hydrogen bomb. But the stars, they do it by pressure, gravity, like our Mr. Sun. So, now I play Mr. Sun and heat the hydrogen and the carbon to 30 million degrees. Fire, 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 fire! Now I am ready. Number 1, hydrogen, come. I, Thermo, now give the command. Fusion. So, what have we here? Nitrogen. The gas what makes 4/5 of the air you breathe. Air. Now number 2 and number 3 hydrogen. Come. Fusion. Now we have oxygen, the other 1/5 of the air you breathe. Number 4. Fusion. Huh? Now we have coal again, same piece. And we have helium, what you fill balloons with. 4 hydrogens, if they are 30 million degrees hot, 30 million degrees. It is not children playing with matches. The 4 hydrogens come out 1 helium. The carbon comes back the same, you see? Same weight, no change. That's why we call this the carbon cycle. Now we weigh the helium. Should weigh 400 ounces like the hydrogen. Oh, yes, naturally. But it can't be. The helium weighs 3 ounces less than the hydrogen. Where did the 3 ounces go? That is the magic of the stars. That is the secret of the hydrogen bomb. I show you. Come back, 3 ounces. Here is where they went. They changed into...
Now, the energy in those 3 little ounces that completely disappeared as matter, that energy is enough to raise the Empire State Building 2,500 miles high. Now, the carbon cycle, which is what Thermo just explained to us, is not the only way in which you can change hydrogen into helium plus energy. You may also use a very special and rare process in which you put two hydrogen atoms together directly.
Is that the famous proton-proton process?
Say, you've been reading. Mr. Sun, you do not annihilate or destroy just 2 or 3 ounces, but 4 million tons of hydrogen matter each second. That gives you your unbelievable energy, which you radiate out into space. We think that originally you were a great loose cloud of gas, mostly hydrogen, being contracted by gravity. As you were compressed, the temperature went up, just as the air in a bicycle tire gets hotter and hotter as you pump it. Finally, the temperature in your core reached the necessary 30 million degrees needed to trigger the thermonuclear reaction. Presto, the furnace was lit, never to go out again as long as you live, Mr. Sun. The hydrogen began burning into helium and energy. Gravity tries to compress you, burning hydrogen tries to expand you. The two forces just balance each other. Oh, it's perfection itself, a furnace made of its own fuel, an immense continuous hydrogen bomb operating at an even heat for billions of years. What a wonderful invention you are, Mr. Sun.
Which brings up a point. How long before he runs out of this here now hydrogen fuel?
Oh, he still has about 98% of his fuel left. But 50, 100 billion years from now, Mr. Sun, you'll perhaps run out of fuel. You'll expire, go wherever good stars go. We'll go with you because as you go, we go.
You see, you're not just a big blob of hot mass to us. You're the head of our family. We want to know more about you. We depend on you for our very existence.
Yes, in fact, we're depending on you heavily for the solution of 2 of man's biggest problems.
Well, at last I'm being appreciated. What did you say your name was?
Dr. Research, you big... What are those 2 big problems you spoke of, Dr. Research?
The first is the age-old problem of food. Roll 5.
And boy, the number of mouths that need food keeps increasing.
In 1650, after 25,000 years of man, our population had reached 500 million. By 1950, only 300 years later, the population climbed to 2.5 billion, 5 times as many. Out of all the human beings who ever lived, 1 out of 20 is alive today.
1 out of 20 alive today?
Isn't that amazing? We never had food enough for all in the past. We don't have enough for all today. 2 out of every 3 persons on Earth actually eat below the minimum necessary for health. Yet 100 million new babies are born every year. A yearly baby crop nearly equal to the population of all of South America.
And all born hungry.
Yes, our population's practically exploding.
I'll bet he doesn't know who grows his food for him.
Oh, yeah, we know quite a bit about that. That is, he does.
Roll 4. Our food is grown by a natural process called photosynthesis, which means putting together with light. Your light, the oldest, biggest, and most important manufacturing operation in the world. 99% of all our food and fuel is created by photosynthesis, a process that goes on only in plants, never in animals. On every green leaf, there are millions of submicroscopic little one-man factories turning out more sugar than all the ships and railroads in the world could carry. And the head man of each factory is a little green molecule called chlorophyll, the only engineer with the know-how about this still secret life process. Chlorophyll is so small and so secretive that not even the most powerful microscopes can spy on him. Here's the way we think he works. The veins of the leaf bring him water from the roots. From the air, he grabs a molecule of carbon dioxide, CO2. He puts a water molecule and a carbon dioxide molecule together. And then he reaches for a piece of sunlight, and this is what we don't quite know, how he adds this sunlight.
And I'm not going to tell you either. You can darn well find out for yourself.
Quiet.
Piece by piece, he adds more sunlight to his sugar cake. And then he pulls out an oxygen atom from the mixture and releases it into the air.
And the Russians didn't invent me either. I invented myself.
And then he takes some salts that come up in the veins, sprinkles them over the mixture for icing, and puts the completed sugar cake into a waiting artery. Out of this sugar or sunshine cake, the tree makes leaves, trunk, roots, and fruit. In the sea, chlorophyll produces even more food than he does on land. The whole surface of the seas is teeming with billions of tons of a minute single-cell vegetable called phytoplankton. These, in turn, are eaten by countless, almost invisible little animals called zooplankton, which are eaten by little fish, which are eaten by bigger fish, which are eaten by still bigger fish. Yes, all fish are ultimately made of chlorophyll sunshine cake. And when we catch them and can them, we're catching and canning sunlight. In fact, all animals feed on sunshine cake in one form or another. The energy that Junior gets from milk was in a contented cow 24 hours ago. And 24 hours before that, the same energy was in clover, which had absorbed it from sunlight that had come 93 million miles in 8 minutes from the surface of the sun, but had taken 20 million years to find its way to the surface from the sun's central furnace. So you see, the energy that makes Junior run, that makes a porpoise leap, and makes me talk so much, that energy is hydrogen that burned in your central furnace long, long before man walked the earth.
You know, Brother Research, I'm beginning to like you. Do all the people know these things about me?
No, that's why this program.
What's the big hitch in the food problem?
For one thing, chlorophyll is too slow. Take any acre of forest or vegetables. The amount of sunshine converted to plant food averages only 2 tons of vegetable matter per year. But if all the light you send us could be used by chlorophyll, we could raise 2,000 tons of food per acre per year.
A little chlorophyll may know the big secret, but he's awfully inefficient.
Who's inefficient? I just make sugar. Can I help it if those silly trees build trunks and branches and roots out of it that you can't eat? What you're looking for is a plant that's all fruit. Oh, there is such a plant. All edible, too. And it multiplies faster than rabbits. But you scientists are too dumb to find it.
There you are, Mr. Man. Find the plant.
Oh, we found it already, Mr. Sun.
Roll 10.
Found it in freshwater lakes. A kind of green algae called chlorella. A tiny one-celled plant that has learned the mathematical trick of multiplying by dividing.
Each cell gives birth to from 4 to 16 daughter cells, which all grow up and repeat the process. Chlorella contains fats, carbohydrates, and up to 50% proteins, and is all edible. All fruit, as Mr. Chlorophyll would say.
All over the world, scientists are doing research on chlorella. In Japan, Dr. Hiroshi Tamiya of the Tokugawa Institute has done some of the most interesting and practical work. For there, food is definitely a problem. Into these troughs, water containing chlorella cultures is pumped. Nutrient salts are added. The troughs are covered with plastic sheeting to let in sunlight, while extra carbon dioxide is bubbled into the solution. When the culture becomes intensely green, the chlorella crop is harvested. After washing and drying, the fine powder looks like green flour. Mrs. Tamiya, wife of the director, has added this to regular flour and made excellent biscuits and cakes out of it. If these processes ever become practical, underfed populations may have a new, rich source of food.
Yes, indeed. An acre of chlorella can convert sunlight into some 20 tons of plant matter against 1 or 2 tons of an ordinary crop. But there's a second great problem facing us eventually.
For thousands of years, we got our fuel from burning wood. Sun power, Mr. Sun stored up in trees. Next, we put animals to work. Sun power from grass. Then came educated power to do work animals couldn't be taught to do. Human slave power to build roads, pyramids, and row ships. Sun power with brains. But slaves had to be fed. So we discovered power that didn't eat, like windmills and water wheels. The machine age was born. But modern machines need to be fed too, fed with fuels. Where do we get the fuel?
from the big fuel man himself. Over the ages, Mr. Sun was kind enough to store them up for him.
Chop for living sunshine. Dig for fossil sunshine. Drill for liquid sunshine. Dams for silent sunshine. Fuel. Fuel. More fuel.
Well, how much fuel's in the bank? How big is the trust fund the old boy left us? Roll 13. Well, suppose all our energy had been deposited in the Sun Power Bank Incorporated, founded millions of years ago, with assets unlimited. In 1850, each American, for instance, withdrew enough fuel from the fuel bank to generate 400 horsepower hours for himself. But nobody worried too much about it. Our assets still appeared unlimited. In 1950, each American withdrew 10,000 horsepower hours from Sun Power Incorporated, while atomic scientists were making some minor deposits. This began to worry us. Our assets were becoming definitely limited. By 1975, we'll probably withdraw 20,000 horsepower hours each. Atomic energy fuel deposits will stave off the run for some time, but there's only so much uranium and thorium in the world, and that will go too.
When the principal's gone, you're going to have to live on your income, huh?
But our income is only about 10% of our power spending. Going to need help.
Every day I send you 1,000 times more power than you use in a year. It's up to you, fellows.
Anybody working on getting power direct from old Blowhard here?
Oh, yes, but not nearly enough. Roll 6B. Some years ago, Dr. Charles Greeley Abbott, an enthusiastic pioneer in solar engines, designed this vacuum-jacketed boiler tube at the focus of a parabolic mirror, which will convert sunlight to engine power. Today, the French Laboratory of Solar Energy has an enormous solar furnace at Montlouis for metal research at high temperatures.
In India, Dr. S. Bhatnagar, the famous Indian scientist, experimented with solar cookers for home use. On one of these cookers, an Indian family can cook its noonday meal with no heat other than the sun's heat.
Some other ways depend on glass. Sunlight coming through a window heats up everything in the room, but heat radiated back from furniture and floor is long heat waves which the window glass stops from going back out, thus trapping the sun's heat.
Is that why greenhouses covered with glass are warmer inside than the air outside?
Right. That's why your closed car gets so unbearably hot standing out in the sun. Dr. Maria Telkes has designed a model house in Massachusetts in which solar heat is ingeniously collected, stored, and distributed throughout the whole house. Now, these are more or less well-known mechanical ways of using sun power directly. But there's exciting research going on with some brand new ways.
You think Mr. Chlorophyll was pretty smart with his tricky sunshine cake that makes food out of your sunlight? Well, the science boys have come up with a sunshine cake that makes electricity out of your sunlight.
Oh, yes. You mean the solar battery?
Yeah.
That's hardly even a cookie yet, let alone a cake.
Doc, that's big news.
Well, the solar battery. Now, held in the sun, this thin little cell, a sunshine wafer we might call it, produces a usable amount of electric current out of the sunlight that falls on it. It was cooked up out of basic research at the Bell Telephone Lab by 3 scientists, Darrell Chapin, Calvin Fuller, and Gerald Pearson.
You know, although this is quite expensive at the moment, the simplicity of this sunshine wafer is startling. I want to bake one for old Glory Puss, Doc.
I'd be delighted.
Well, get him. Old pastry cook research.
The recipe for this solar wafer sounds just like a vacation. Just sand and sunshine. Thank you, son. Plain old sand is composed of silicon and oxygen. Its Sunday go-to-meeting name is silicon dioxide. Separate out the oxygen and the bits of seaweed, bottle tops, and other odds and ends, and we have left a metal, silicon. Ah, but our silicon must be pure silicon. So we purify it and purify it until it's as pure as the driven snow. Now melt the silicon and add just a pinch of arsenic for flavor. Mix thoroughly and cool until it crystallizes. Then from the arsenic-flavored silicon roll, slice off a razor-thin wafer. Put the wafer into the oven. Fill oven with a boron gas and bake to white heat. The boron cooks into the surface, forms an extremely thin icing over the wafer. Remove finished wafer. Connect one wire from electric motor to boron icing and the other wire to the wafer itself. Expose wafer to sunlight. Presto! The motor starts running with the efficiency of an automobile, and nothing is used up but the sunshine, which is free.
Ain't that something?
Well, I'll be darned.
So you see, in a solar battery, it's energy from the sun that moves the electricity, which in turn rotates motors. Or as in this case, powers rural telephone lines by charging storage batteries. But the solar battery isn't all. There's other important research in changing sunlight into power. Dr. E.I. Rabinowitz has put together a chemical cell that'll change light waves into electric current. But storing sun power for night use is a big part of this energy from sun problem. Well, Dr. Lawrence J. Haidt of MIT is experimenting with a process in which sunlight decomposes water back into oxygen and hydrogen, the hydrogen being a storable fuel. Another possibility, phosphors are chemical powders that absorb sunlight and can give it back slowly in the dark.
I read where Westinghouse engineers predict a wallpaper containing phosphors which will absorb daylight during the day, then glow for hours after dark. A city painted with phosphor paint of the future might glow all night.
These are some of the processes that are being researched on a small scale today, Mr. Sun. But our engineers can't turn the wheels of industry on little wafers. They'll have to build efficient generators that spread out over acres, even square miles, to compete with the cheap coal and oil still available to us.
But Doctor, what about atomic power?
Oh, great hopes for it, of course. Especially now, since atomic plants can make their own fuel with so-called breeder reactors. Some even dream of imitating the stars, getting power from hydrogen fusion. But if dreams fail, the answer must be sun power from our Mr. Sun.
What if you don't find ways to use my free sunshine for fuel?
Then the machine age is over. We'll have to go back to muscle power and the 500 million population that muscle power alone can support.
But that will never happen.
Oh, no? Why not?
Because man's greatest power source is his mind. God gave him that, not you. Without taking a step, he can travel faster and farther than any animal. Without even getting wet, he can outswim any fish. Without a feather on him, he can fly faster, higher, and farther than any eagle. He can send his eyes and ears hundreds of miles into space where he's never even been. And he's pried open the secret of the atom that he's never even seen. When his fuels run low, man's mind and imagination will meet the challenge and invent undreamed of ways to use the free sunlight God showers down upon him. Just remember, somebody must love you very much. That planet that you live on is not like all the rest. You're blessed with just the right size, the right temperature, the right atmosphere, the right composition. Everything just right to produce the biggest miracle of all, life. So go ahead, ask, Inquire, seek the truth. It's right that you should know, or the good Lord wouldn't have given you that driving curiosity. Measure the outside with mathematics, but measure the inside with prayer. Prayer is research too. Study man as well as the world. So keep on pitching. The best is yet to come for you. I predict man's next great adventure will be the Sun Age. When that happens, you'll be rich beyond all dreams. I predict great sun cities built on desert wastelands where everything is run by sunlight. I predict...
Oh, sure, that's fine. But suppose I begin cutting up, then what?
You won't. But if you did, man has migrated many times before, and he'll do it again if he has to. Hey, if you make it too hot for him on Earth, man is capable of conceiving a way to move the whole kit and caboodle to greener pastures on some other planet.
Oh, no, we like it here. Don't change on us, Mr. Sun. We used to worship you as an unknown god. But now that we know you better, we love you as our great and good friend. So keep on shining, Mr. Sun. Thanks for all the radiant riches you shower down upon us. Thanks for our eyes and all the glories we behold. Thanks for all the green forests, the great deposit of black diamonds, and the deep pools of liquid gold you put in the bank for us. Thanks for the wheat fields and all the fruits and flowers you grow for us. Thanks for feeding our animals, our birds, our insects, and all the fish in the sea. And thanks especially for the glory and beauty of your good mornings and your good evenings. In the words of St. Francis, be praised, my Lord, in what you have created. Above all else, be praised in our brother, Master Sun.
Good night, Brother Earth. Now you're cooking with sunshine.
Telephone System takes pride in bringing you this program in its series of shows on science. We wish to express our gratitude to the distinguished Board of Advisors who guide the choice and treatment of scientific matter for the series. For the program you have just seen, our thanks to the special advisors who have suggested and checked the scientific material. The Bell Telephone System is indebted to all these men and to many institutions for the generous support they have given this venture in public education through entertainment.